let's get into the swing of things. Today we will be talking about the physics of swings. Now, swings were probably a part of your childhood, so even just as a kid, swinging up and down gave you ideas about energy, dynamics, and physics. If you pushed harder, you'd swing higher, and that would keep you in motion. Right before the swing started falling down, you grasped that moment of weightlessness, and if you stopped using your legs and your body, eventually you'd stop. Although you probably didn't know, these experiences gave you an advantage in one of the most classical physics problems, the pendulum. When you consider a swing, or any pendulum for that matter, it is surrounded by so many forces and contains large amounts of energy. Let's take a closer look. Looking at this pendulum, we can see that it swings, goes up to a maximum height, stops, changes directions, and then repeats. This is because of the law of conservation of energy, which says, energy can neither be created nor destroyed. Rather, it transforms from one form into another. When the mass starts ascending towards the maximum height, it gains gravitational potential energy while losing kinetic energy. And then, as it changes direction and starts swinging, this mass is gaining kinetic energy and losing potential energy. This process repeats over and over again as the swing is in motion. So because at this point, the swing has the most kinetic energy, this is where the maximum velocity of the pendulum occurs. Now, what's unique about a swing is that in addition to the changes in energy, we need to consider the circular motion of the mass. If I spin a string like so, I feel a force that's pulling this key away from my hand. That is the centrifugal force, also known as the force of tension in the string. Notice that this is the same as the centripetal force or tension pulling the mass. Basically, the tension pulling my hand is the centrifugal and the tension pulling the mass is the centripetal. Now, how do swings work? Well, let me show you. As you can see, I reduced the length of the pendulum when the mass is at the center or lowest point in the circle. What happens is the mass experiences a maximum centripetal force and force of tension at this point, and by pulling on the rope, the centripetal force increases. At the point where the mass changes direction, it's stationary, which means there's no centrifugal or centripetal force and negligible tension in the string. If you reduce the length of the pendulum at the ends, nothing will happen. But if you reduce the amplitude at any moment in between, the mass will swing. The most optimal point, however, is at the center. The same thing happens when you use a swing. Although I'm not pulling on the chains directly, I'm still reducing the length of the pendulum. It turns out, if you look at the way my hands are pressed against the chains, you will see that as the swing bends around my hand, the total length from the top of the pendulum to the swing decreases. So as you're swinging, this is the shape the swing makes in the air, and at that moment, the length of the pendulum is shorter than it was originally. So as you pump your legs and move your body, you're really just pushing or pulling on the chain to make the pendulum shorter. Today, swings may seem like a simplistic part of every kid's childhood, but their technology is found more often than you think. For example, most backyards or terraces nowadays have canopy swings or hammocks. These are more contemporary versions of the classical swing, which are now integrated as part of furniture. Even cooler is the new technology of swings used in rides at amusement parks. These rides incorporate the technology of swings into large, fast, and exciting rides like the Cyclone at Canada's Wonderland or the Fireball at the CNE. These rides and playground swings are also very environmentally friendly. In a regular swing or an amusement park ride, much less energy is required to keep it in motion, as it loses minimal energy to friction, heat, and sound. Once in motion, the only energy required to keep it in motion is the energy lost through these means. The materials used in most playground swings are often durable and cheap, since most swings require minimal materials and a simplistic structure. Because of this, swings and most pendulums are energy efficient and environmentally friendly. Since pendulums are extremely environmentally cautious, They are applied to many already existing technologies. A mechanical metronome or clock is much less demanding of the environment in the same way that swings require minimal energy input once already in motion. Mechanical objects require much less modern technology, such as batteries, motors, and programming, while the materials used in digital purposes require a lot of consideration and often need costly materials that are less likely to react and overheat. Because of this, engineers have been incorporating the technology of pendulums into everyday life since the 17th century. They are constantly altering, improving, and incorporating this efficient and effective technology into more and more popular means in our society. Pendulums can be found inside metronomes to help musicians keep a steady beat, grandfather clocks to keep a stable tick, seismometers to measure the size of earthquakes, and even buildings. The Taipei 101 uses a pendulum to stabilize the building. And this is only the beginning. Researchers are constantly searching for new and innovative ways of applying this technology into our society. Pendulums are something we have become very familiar to, as we always find them in our physics tests, and as they're more and more popular in our society. Yet, I think the greatest impact they've had in our lives is in our childhood. Swings give you a feeling of flying in a controlled manner. You pump your legs to provide enough force to increase the height of the swing's arc, and enjoy the increased velocity of the downward swing. For brief moments, you feel weightless, and when you're done, you just sit back, relax, and let friction do its work.